Welcome to my presentation about RTC security. In this presentation, I'll be giving my thoughts, my ideas about real-time communications security, and I'll be explaining why I think that real-time communications vendors and service providers are in trouble, despite maybe having done some defensive approach towards security. I'll be talking therefore about defensive security, that is, taking specific measures to prevent attack, and I'll be talking about, of course, my favorite topic, which is offensive security. And the focus is not about security in general, but rather voice over IP and WebRTC infrastructure security. But first, I should introduce myself. I'm Sandro Gauci. I lead Enable Security, where we develop offensive security tools, and we use those security tools when we provide our services, which consist of penetration testing, security testing, especially of RTC systems. We have published security advisories, security tools, and presentations about our security research in this area and other areas as well, such as web application security. But I'm personally best known to this community as the author of SIPVicious. I had open sourced SIPVicious back in 2007, and yeah, I've been into VoIP security since then. I was, of course, a bit before I open sourced it, but yeah, into security also since 20 years. So here's the mascot for SIPVicious, just in case anyone needs to see that. But let's skip to the main topic, RTC security. So what does RTC security mean? What do I mean by real-time communications security? And I think this means a different thing to different people. So different people, different organizations have different needs when it comes to real-time communications. For example, if you're a privacy-focused organization or group, then that for sure means encryption. It might also mean hiding the metadata. If you are a telco, then that for sure means that you don't want anyone messing with your billing, so fraudulent voice over IP calls are a big problem there. If you're a service provider of some sort doing real-time communications, for sure denial of service is going to be a problem. Yeah, a denial of service is one of those things which stop your business from generating money. Every second that your system is down, that's money is lost. So that's maybe what RTC security means. And I think we cannot talk about security without dividing it into confidentiality, integrity, and availability. So here's the picture that you usually find when you Google that. Exciting stuff. All I want to say about this is that it's good to think in terms of these three different components of data security. It allows us to describe things better. But also we need to definitely talk about threat modeling. And threat modeling, this is the Wikipedia summary. Threat modeling is a very important, I think, exercise which allows you to identify what you want to protect against who and how much resources you need for that, and so on and so forth. So you actually understand where you are in terms of security. So threat modeling and offensive security, when it comes to threat modeling, a lot of organizations do it. Organizations within RTC, that is, do it either consciously or subconsciously as a byproduct of other exercises. It's being done. Of course, you do find the occasional company here and there that does in the real-time communications world that might not even do that, but we've seen it being done. However, when it comes to offensive security within the real-time communications world, it's not so common. We don't see companies doing offensive security when it comes to, specifically when it comes to RTC, their RTC infrastructure and applications. And what do I mean by offensive security? I mean, I like to describe it as thinking evil or asking what could possibly go wrong and acting on that. So the next slides are going to be something like this. First, I'm going to describe the solutions that organizations might deploy or employ when protecting against a particular threat. Then I'm going to describe what we see when we take an offensive security approach sometimes. And of course, we're going to demonstrate some of these things when we have a demo. So the first example I have is about transport security for signaling and media. What I mean is when you're trying to address confidentiality concerns in the voice over IP world, you're probably going to use SIPTLS instead of plaintext SIP and SRTP. In the WebRTC world, it's enforced to use signaling over TLS and the TLS and SRTP. So those are straightforward solutions, and many organizations who are concerned about the confidentiality of their video or voice calls will make use of these solutions. So the first story I have is the story of an SBC, which was configured to make use of SIPTLS, SRTP, and SDS. They were enabled, enforced. And so, from a configuration point of view, it looked fine. It would have passed with flying colors from a security configuration point of view. A network capture would also have shown that everything is encrypted, but when we started doing a secure code review, what we noticed is that the SBC, which was terminating the SRTP and generating the SDS keys, therefore, was making use of functions that were not cryptographically secure for generating the key, the SDS key. So we ended up copying the code that was used for generating this SDS key and using that for brute force purposes and realizing, hey, it's very, very easy, actually, in this case, to find the key because there were only a small limited amount of keys that could be generated. It had a low entropy, we would say. So that's a way that offensive security helped there. The second story on this topic is involves SIPTLS, a server that is configured to allow SIPTLS, but SRTP on the client was not configured and it's not being enforced. And unfortunately, this is a very common scenario that we find. So let's do a demo for that. So essentially we can look at a packet capture and it shows that encryption is being used. We can see that port 5061 is indeed, that's where SIPTLS is flowing. So this looks like typical TLS. There's the certificates which are in clear text. That's fine, but the rest is encrypted. But then you scroll down a little bit in this PCAP, in this packet capture, and you see a lot of UDP packets. And what you can do in Wireshark is you say decode as RTP, and then you can open the RTP stream, analyze, and actually play the RTP stream. And this shows that the RTP stream is not actually SRTP, but it's plain text. And this is something that we've seen in a couple of deployments. There were cases where it was hardware that was configured in this way. There were cases where software phones were making use of SIPTLS, no problem, but the RTP was not being encrypted. And it's not very straightforward if you simply sniff the network traffic. So that's why you need to actually look at what's happening there. So the next example I have involves denial of service attacks. Most solutions involve rate limiting and firewall rules. Firewalls are used not only in the network world, but also often in the real-time communications world. And also, many solutions involve blocking IP addresses of offending IPs. So we have a graph here, and what I'm trying to show here is an example where the administrators for an SBC, for example, have decided 400 messages per second is the right rate limit. Anything beyond that, we're going to block that, we're going to blacklist it. And so an attacker who sends a large number of SIP packets doing an invite flood, for example, or something like that, will trigger that and get blocked. But let's say the attacker found that a particular SIP message, say the subscribe SIP message, is causing some extra CPU cycles. Maybe the attacker realized that when they send this particular malformed SIP message, it's responding with a particular error much later. Then that might mean that such a SIP message is generating a lot of CPU cycles. So what an attacker might do is they might try to find the rate by simply increasing their attack rate, packet rates slowly until they get blocked from one IP, and then simply go under that rate. And if they do that, and they find out, hey, this is causing some lag, some problems, they can simply replicate the same attack across different IP addresses. Each time, this would end up taking even more resources on the target system and causing a major denial of service vulnerable attack. And then the second example that I have, we have a demo for that. So let me show the network diagram first. So what we have is a SIP client, Zoiper, the target server, which is a PBX that is connecting to a SIP trunk over the internet. And in this case, we have an attacker. It happens to be in the same environment. And the PBX actually has failed to ban, so that anyone who does any attacks gets banned. So let's start this demo now. So on the left we have the SSH, the asterisk system, and just gonna connect to asterisk to show the console. And then we can show that a phone call can be done, an international phone call can be done through the PBX, which is actually doing it through a SIP trunk. Alright, we hang up. That goes through, no errors. And so the attacker now can start their attack using Scapy in this case, an open source Python library for doing attacks and tool as well. And so what the attacker is gonna do is they're going to spoof the IP addresses of the SIP trunk. The SIP trunk actually has 3 different IP addresses in this case. And they have a SIP packet that is known, when repeatedly sent to the target system, is known to cause it to create a new IP tables rule thanks to fail to ban. So okay, so we're going to go through each source IP address in which we're going to spoof and send 100 invite packets like that, spoofing the SIP trunk. So using the send function, and these packets are being sent. Now I'm going to try to make another call like before. So we write the phone number on our software client, and then we can see that the call gets rejected, and it's the if one can spot the error in the console on the asterisk console, then you can see that it says cannot create an outgoing session to endpoint, and it mentions the SIP trunk. And yeah, we can simply show that fail to ban has actually blocked these IP addresses. So the next example involves caller ID spoofing. When it comes to caller ID spoofing, I think lately it's been a lot on the news because of Stirshake, which aims to address spoofed calls in the US especially. It's a security solution to this, and also there are laws being made about this, so it's pretty interesting. And also, if you're running a SIP trunk or some service provider, then you're probably removing the p-asserted identity headers at the edge from untrusted user agent clients. So the first example I have is regarding Stirshake. Now I have to say that we don't have an excessive amount of experience in this. So we were trying to learn about this, and for a recent event, OpenSIPit, and where we were going to test this. And so we were doing a bit of fuzzing, and the implementations that we saw were all very immature. They were not at a decent stage, but we did some fuzzing anyway. And the first thing that we noticed is that after a few seconds, the SIP server that we were targeting was crashing, and this was because the JSON parser was crashing. And essentially, this is the result of Stirshake making use of JWT, and the SIP the parser for JWT tokens was using some problematic JSON parser, and so that's what happened there. Now, my point is, with Stirshake and similar solutions, there's a lot of security technology being employed there, right? You have certificates, you need to be getting certificates from an HTTP server sometimes. You need to do JWT verification with certificates and so on. So it kind of increases the attack surface by quite a bit, and these things, they all need to be somewhat tested. So the next demo that I have involves caller ID spoofing against a Cameo server. Now we have a video demo for this. So you have a normal Cameo configuration with remove HF, and this works fine. This is how it's supposed to be used, and remove HF is removing the p-asserted identity header incoming for any incoming SIP messages. And we can see that if we add this header to a SIP message and send it over to the Cameo server, the incoming call doesn't get spoofed. Now let's say someone actually decides to start keeping track of the p-asserted identity headers for any reason. And the administrator implementing this change decides to make use of the replace HDRS function in this case. So they make use of that function and start replacing the p-asserted identity header, and then you can see that it still works. It does get replaced and doesn't get passed this p-asserted identity. No spoofing happens. But if the attacker, say, puts the header twice, it's only the first header that gets replaced. So, you get phone caller ID spoofing in this case, which is pretending to come from 911. So the last example that we have involves a WebRTC infrastructure with a turn server. Now, someone setting up a turn server on the internet might actually have read our blog post about our Slack bug bounty submission involving a turn server, and therefore set up some rules and configurations in their co-turn, for example, the most commonly used turn server, to block localhost 127.0.0.1 or maybe the whole /8 subnet and so on, and perhaps even turn on TLS, because security, right? Let's make a demo and show what could go wrong in this case. So this is our demo. It involves having a web server which has a hidden area called secret, and if you go over the internet for this area to try to access this area, it's not accessible. It's only accessible to localhost, and no one else gets a forbidden page. Now the turn server is being started with a certain number of rules. You can see a number of denied peer IP addresses, ranges of IP addresses that are being denied. There's 127.0.0 till 127.255, 255.255, and so on and so forth. And therefore, if someone were to abuse this turn server to connect to 127.0.0.1, for example, and access that secret area, they would not be able to do so. So I'm going to show that. We start our tool called Stunner and try to access 127.0.0.1/secret, and it's unable to connect because the IP address is forbidden by the turn server. However, if we make use of 0.0.0.0/secret, then we can access that secret area, and in this case, shut down the internet. So that was the final example of what could go wrong when there is no security testing, no offensive security approach is taken. So why offensive security? I guess by now it is kind of obvious. It's because you don't know what you don't know. That's why we need to take a defensive security, an offensive security approach to think evil, essentially. So if you did do some threat modeling, offensive security will help you validate your threat model, because it's very easy to imagine that you have a certain set of threats, while in reality, if you get a penetration tester or a real hacker or some sort of adversaries, they're going to attack something else in your RTC infrastructure. So with offensive security, you can validate your threat model. And apart from that, implementing security solutions without having actually tested them, well, that's inviting trouble, because you don't know if they're really working. I mean, sometimes you can tell yes or no, but they might be easy to bypass as well. So, it might be working, but there might be an easy way to bypass such security solutions, as we showed during our demonstrations. And apart from that, and this is one of my bigger worries, many security solutions increase your attack surface and therefore introduce new security issues. Security solutions, they mean extra code, and in some cases, a lot more code. So that means that they can be also vulnerable. So to get value from offensive security, I think its value is proving that there is a vulnerability, and it's hard to argue about that sometimes. Sometimes we do some security tests, pen tests, and give the developers a report or tell them, hey, we found this particular issue and we have not yet demonstrated it. And the developers tell us, but we did protect against this particular security issue. But it's really then hard to argue with us when we show you a database dump or something like that. It's good proof, right? So again, to go back to our first part of this talk, security means different things. And threat modeling really helps determine what those things are. Offensive security as well, but it also tests the security solutions. So is it offensive security versus threat modeling? Well, I would say no. Actually, I think they have to work hand in hand, and one needs to inform the other. So when it comes to offensive security, well, it doesn't work too well if you don't have a valid threat model, because there's so much that can be tested, right? So a valid threat model helps you focus. On the other hand, offensive security helps you validate your threat model. So they are really part of the same solution. And something else, though, that I should mention, running a pen test doesn't mean you're secure. Okay, we often hear companies say, "Oh, we ran a pen test." What do you mean by that? Well, probably what they mean is that they ran a security tool that told them you have no problems. Or maybe they mean that they got a pen test company to do their services and told them, yeah, you have these problems, but really nothing with regards your RTC systems. And so my argument to that is, one does not mean the other. Pen test does not mean you're secure. You need also to get to actually know what you're testing when it comes to RTC. You need the knowledge and so on. And you also need to be able to fix the problems that you find during a pen test. It's not enough to do a pen test, you need to actually go and do the work afterwards as well. And yeah, so even though ethical hacking and so on is the full range, it's really popular at the moment, it doesn't really solve the problem on its own. In fact, what we see is that it can give you a false sense of security. So where are we when it comes to the RTC world and security? Well, unfortunately, and this is part of the problem, I think a huge part of the problem is that we have outdated penetration testing techniques when it comes to voice over IP security. What do I mean? Well, if you look up on Google VoIP pen test or something like that, you mostly find things about voice VLAN hopping, SIP extension enumeration, and things that are really outdated, and many RTC systems have actually either addressed or just given up on. Unfortunately, there are barely any publications when it comes to RTC security test, web RTC security testing, so there's not much happening there. When it comes to WebRTC infrastructure security testing especially, there's a huge lack of that. So my talk here is really about asking you, the audience, to start thinking evil when implementing and when coming up with security policies and security solutions. Thinking something like, how could this be broken? What could go wrong here? Is it far-fetched or not maybe? I'd like to see more efficient tools to detect and demonstrate security issues. Most of the tools out there, especially the open source ones, but closed source, there isn't all that much either, are not updated. They are not well maintained. I'd like to see more knowledge being shared on testing the security of real-time communications systems and more offensive security research out there. And of course, I'd really like to see some security testing methodology. We have our internal one, but it would be great if there's something a bit more like OWASP did with the web application stuff. And finally, all of this would be boring, right, if we couldn't play a bit. So I really think it's a great idea to have playgrounds to play with, to test things on. So I've come to the end of my presentation, and I'd really like to thank Alan for the invitation for this presentation, and also my colleague Alfred. He's been working on this presentation as well, and the demonstrations and the videos. And if you want to follow our work, we have a blog on real-time communications security. We're publishing stuff as fast as we can. We're making things available, our research available, security advisories, and so on. And if you want to get in touch, of course, send us an email. So thanks for watching.